In this lesson, we're going to continue finding the exact value of a trigonometric expression. We're going to continue using the sum and difference formulas, and I'm working off problems from page 521. All right, in these problems right here, it says find the exact value of the trigonometric expression when sine of an angle U is equal to 5/13 and cosine of angle V is equal to negative 3/5. Both angle U and angle V are in quadrant 2. All right, these look a little different than the previous problems that we did. We're not using the unit circle. We're actually going to be using some right triangles to help us find the exact value of cosine U minus V. All right, it tells us that both angle U and angle V are in quadrant 2, so what we're going to do is we're going to draw two coordinate planes over here. This is going to be the coordinate plane for angle U, and this is going to be the coordinate plane for angle V. So both U and V are in quadrant 2, so quadrant 2 is over here. So let's draw two right triangles. So this is angle U inside the right triangle, and this is angle V inside this right triangle. Okay, let's go back to the given. It says the sine ratio of angle U is equal to 5/13, remembering that sine is opposite over hypotenuse. So here's angle U, opposite from here is 5. Hypotenuse, which is always positive, is 13. Cosine of angle V, so here's angle V, is adjacent over hypotenuse. So for angle V, the adjacent side would be here. This would be negative 3. We want the negative to go with the 3 because the 5 is the hypotenuse, and the hypotenuse is always positive. And because we're in quadrant 2, remember the x-coordinate has to be negative. Okay, now we're going to actually have to use Pythagorean theorem to find the missing sides here. So using Pythagorean theorem, this actual value is going to be 12 for that length, but remember we're in quadrant 2, so you want to go ahead and be certain to put the negative there. Okay, over here, if you use Pythagorean theorem, you're going to find that this leg length is 4, and because I'm going up vertically and I'm in quadrant 2, that's going to be a positive 4. All right, let's go back to our problem. 45 says find the value of cosine of U minus V. This is a difference of cosine formula. So cosine of the first times cosine of the second, because this is cosine, that minus changes to a plus in the formula. And then you find the sine of both angles multiplied together. Same structure as last time. We have to find 4 values and multiply and then add. Okay, cosine of U, make sure you go into the U triangle. The cosine of U is going to be adjacent over hypotenuse. So cosine of U, which we were not given, is going to be negative 12/13. Now cosine of V, that would take you over here to this triangle, right here, a V triangle. Well, the cosine of V is adjacent over hypotenuse, but that was given. Let's go back and find the sine of U. Well, here's the U triangle. The sine is going to be 5/13. That's what was given. But now we need to find the sine of V. Sine of V. So come over here. We don't have the sine of V given, so we're going to have to use opposite over hypotenuse, so that's 4/5. So now we just have to deal with some fractions. So multiplying these two fractions together, let's multiply the denominators. You're going to get 65, and the product of the numerators is 36. Moving over here, the same denominator, 65, and the numerator is 20. So keep the same denominator, add the two numerators, and the final answer is 56 over 65. All right, we're not able to check because we didn't have anything from the very beginning here, but rest assured we did this together, so our answer is 56 over 65. All right, let's look at example 47, which came from page 521, or in that section. Okay, so let's find the exact value of the trig expression, tangent of U plus V, when the sine of angle U is negative 7 over 25 and cosine of angle V is negative 4/5. Further tells us that both angles U and V are in quadrant 3. So same setup. Let's draw a coordinate plane. This will be the coordinate plane for angle U and the coordinate plane for angle V. This time we're going to put the two right triangles in quadrant 3. So just be real careful with our positive negative signs. Remember that both legs would have a length that, well, the length's always positive, but we assign negatives to them. All right, so let's go back to the given here. Sine of angle U, here's the coordinate plane for U. Sine is opposite over hypotenuse. So this is U. Opposite is going to be the -7. Hypotenuse is the 25. It's always positive, the hypotenuse is. Cosine of angle V, here's angle V, is adjacent, so that would be -4 here. And 5 is the hypotenuse. Okay, we're going to have to use some Pythagorean theorem to help us find the missing sides. So if we did that with Pythagorean theorem, this is going to be a distance of 24, but remember we're in quadrant 3, so that has to be negative. Likewise, this is another 3, 4, 5 triangle, so this is 3, but remember it's negative. If we don't get the positive and negative signs right, that's going to make our answer over here off. All right, let's go to our formula sheet. Let's find the sum of tangent formula. So it's tangent of U plus tangent of V over 1 minus the product of tangent U, tangent V. You can use parentheses or not, doesn't matter. Just be careful. All right, so what's the tangent of U? Let's go to the U triangle. Tangent of U is going to be opposite over adjacent. So we're going to have 7/24 plus tangent of V, opposite over adjacent. So that's 3/4. Then in the denominator, I'll multiply these two values. Okay, it's a little bit complicated here. I'm going to clean up the numerator, maybe getting a common denominator, and then I'll clean up the denominator, getting a common denominator, and then I'll probably multiply by the reciprocal. All right, so my next move, let's see if I have some room here. Might be kind of tight. In the numerator, let me focus my attention on this numerator right here. I need a common denominator of 24. So that means multiply this second fraction by 6/6. So I'm going to get 24 as my denominator in the numerator. So that's 24. 24 here, 24 here. And then I'm going to have 7 plus this product is 18. So that's 25. So this whole numerator cleans up to 25/24. Now going to the denominator, I've got 1 minus. I've got to multiply these two fractions together. Before I multiply them, I actually might see that if I'm multiplying these two fractions to make the number smaller to work with, I'll divide a 3 out here and a 3 out here. So what's left is on the top is I'm going to have 7, and in the bottom, 8 times 4 is 32. Let me come up here, it's getting too crowded. (7/32). I'm going to continue cleaning up the denominator. To get a common denominator, I'm going to change this 1 whole to 32/32. So 32 minus 7 is 25/32. So I'm going to keep the numerator. And instead of dividing, I'm going to multiply by the reciprocal of the denominator. So I'll flip that fraction, 32/25. And I'm going to look to see if I can cancel anything before I have to multiply and get large numbers. Yep, 25 divides out with 25. And notice that 24 and 32 have a common factor of 8. So 8 goes in here 3 times and 8 goes in here 4 times. So finishing multiplying the numerators and the denominators, I get 4/3. That's a ton of cleanup. We're out of the pre-cal right here, and then the rest of it is just kind of doing some computations with some previous math classes. All right. Okay, let's continue using sum and difference formulas, but in different contexts. Okay, so it says in 62 and 68, we want to verify these identities. To remember about that process, we take probably the more complicated side of the equation and we work only on that side until we get the other side of the equation. So in 62, I would say that this side of the equation looks more complicated than sine x. So this is where our sum and difference formulas come into play. So I see sine and I see a difference. So I'm going to apply the difference formula for sine to this side of the equation. So remember, this is u and this is v. I'm going to go ahead and find this trig value right here. So if you go to the unit circle and you find 3 pi is all the way around and then halfway around. So you're right here at the ordered pair -1, 0. So that's x, that's y. So the sine of 3 pi is 0. So 0 times cosine of x is just going to be 0. But over here minus. What's the cosine at 3 pi? Well, that's going to be -1. So I'll have -1 here. And sine x I can't simplify. So this whole term goes to 0, then I have a negative of a negative, which is positive, resulting in sine x. So I ended up proving or verifying that identity by using the difference formula for sine. All right, 68 is the same objective. We're going to verify the identity. It does get a little more involved, so hang in there. I'm going to work on the left-hand side of the equation because this is where I'm going to be using my sum and difference formulas. So I want to make this side of the equation look like this side of the equation. Notice that you have sine squared x minus sine squared y. All right. So what we're going to do first here is this. I'm going to identify that I'm going to use the sum of sine formula here. And then for this factor right here, I'm going to use the difference of sine formula. So let me work on the sum of sine formula first. Remember, this is u and this is v. So all of this right here is just from the sum of sine formula. But then what I want to do is I want to multiply that by the difference of sine formula. I'm going to do some brackets here. Okay, remember this is u and this is v. So it's sine of the first times cosine of the second, which is y, minus cosine of x, sine of y. Okay, so all of this right here came from the difference of sine. Okay, so now I'm supposed to multiply these two together. Okay, well, here's your first term, here and here, and here are your two last terms. Well, let's just study these real quick. I have a sum and difference, and these two terms are the same, they're alike, and these two terms are the same, they're alike. I could FOIL, but what's going to happen is when you have conjugates, you don't have to do outside and inside because they cancel. So let's just multiply the two first terms together and the two last terms together. So that means I'm going to multiply this term times this term. So multiplying these four numbers together, I'm going to get sine squared x times cosine squared y. Now multiplying these two last terms together right here, this term and this term, I'm going to get minus, and then these multiplied produce cosine squared x, sine squared y. Okay, let's stop right here and think about what we have and what we're trying to get. We don't need cosine squareds in our answer, so that kind of suggests that let's get rid of the two cosine squared terms by using a Pythagorean substitution. So for this first term right here, I'm going to keep the sine squared x because I want that to be part of my answer, but right here where I see cosine squared y, I'm going to change that to 1 minus sine squared y. Minus, now come over here, I don't want cosine squared x, it's not part of my answer, so right here where cosine squared x is, I'm going to change that to 1 minus sine squared x. And then don't forget to multiply by sine squared y behind it here. Okay, so where we're at here suggests that with these two terms that maybe I distribute inside these factors. So at this point, I'm going to distribute sine squared x in. So I'm going to get sine squared x minus the product of these two would be minus sine squared x times sine squared y minus, I'm going to put a big parenthesis here because I'm going to distribute this sine squared y from behind, but I've got to subtract everything I have. So distributing in, I'm going to get sine squared y minus, now when I multiply these two, it's minus sine squared x sine squared y. Okay, now the next thing that is suggested here is I take the opposite of both of these terms. So I'm going to bring down these two terms here. Distribute the negative inside, minus sine squared y, and then minus a negative is plus. That whole group right there. Because all this is joined together. Now notice that these two terms are opposite. They're exactly the same. They're opposite, so they cancel. So I'm actually left with, I'm going to come up here, I'm left with sine squared x minus sine squared y, which is what I was trying to get. And then I'll bring over the answer. Whew! That was a lot. We used two sum and difference formulas right here, and we observed some structure here to where we didn't have to do the whole foiling. We did a Pythagorean substitution, we cleaned it up with the correct algebra, and we did verify the identity. Okay. All right, this is problem number 70 in that section. It changes a little bit, but we're still going to be using the sum and difference formulas. However, the objective is a little different. We're not verifying or finding an exact value of expression. We're actually trying to find any solutions or solution of this equation as long as those answers fit between 0 and 6.28 or 2 pi. So we're supposed to find the solutions. We're supposed to solve this equation. Okay, when I take a look at this, I see the structure on the left-hand side is suggesting that I might use the sum of cosine formula here and the difference of cosine formula here. So if I'm going to do that, remember these are u and v. Okay, so I'm going to work first of all on using the sum formula for cosine here to find that exact value. So cosine of the first times cosine of the second, I change to minus, and it's sine of each of those. So I'm done applying the sum of cosine formula. Let me apply the difference of cosine formula here. So minus, and I'm always mindful of putting a bracket or a parenthesis after a minus, because if I have multiple terms here, I've got to distribute that negative in. So let's go ahead and use the difference of cosine formula here. So cosine of the first times cosine of the second, but we change to a plus, and it's sine of the first times sine of the second. Close your bracket. Remember, this is an equation. We're not proving an identity. We're trying to solve this and find an answer. Okay. You might notice that when you distribute the negative inside to this group, those two will cancel. So I might do that first. Remember, that's all grouped together, so it's just one minus in front of the product cosine x cosine pi over 6. And then distribute that negative in. And we did that distribution first because we saw that, let's see what terms are going to cancel. Not these two, these two. This one and this one, they're opposites. Okay, notice the two remaining terms are exactly the same. So I have two of these, but they're both negative. So when I collect these two together, they're identical. That means I have negative 2 sine x sine pi over 6. I don't know, I might change this to a value. So what is sine of pi over 6? So we'll go to your unit circle. the y-coordinate at pi over 6 is a half. So I have negative 2 sine x from that factor times positive half equals 1. Yes, I can multiply negative 2 times a half, and that means I have negative 1 sine x equals 1. Let's take the opposite of both sides. So I'm going to have positive sine x equals negative 1. Remember, our objective is to solve this, find solutions. So we can go to the unit circle. What angle on the unit circle has a y-coordinate of negative 1? So you're at negative 1 down here, and that angle is 3 pi over 2. So this solution is x equals the angle 3 pi over 2, having the y-coordinate of negative 1. So there are many ways that we can use our sum and difference formulas. We can use them to find exact values. We can use them to verify identities. We can even use sum and difference formulas to solve trigonometric equations. All right, that's it.